Hello everyone. I hope you found that previous video with that quick look type overview stuff for the RTCC. In this one we will be doing tutorials for the calculation of a translunar injection, as well as the abort pads that come with them, and possibly undocking. So undocking is like a part of calculating those abort pads, but I don't know if we'll actually get to the undocking in this video. I'll make that up a little bit later. So yeah, well, I'm gonna go ahead and do the liftoff and then the orbital insertion checks, and I'll be back with you once that is all done. Oh, and then there is one thing I forgot to point out. To use RTCC, it's recommended if you're using these pre-built missions, it's recommended that you disable mission tracking. So hit tab and 9 to go to debug, and then you're just going to go ahead and toggle empty mission tracking. You still want the ground track because it's nice to have those AOS and LOS messages appear, but you'll want that mission tracking disabled. I'll see you guys after the orbital insertion checks. Okay, and we're back. We've completed our orbital insertion checks, so we can go ahead and bust out the old RTCC. So go ahead, select RTCC, and the first thing remember is, just if you haven't already, configure your CSM. And now that you're in orbit, you can go ahead and update your liftoff time, and we'll take it from the CMC. So just type CMC and enter. You'll see that small update there. Now you'll go to utility and the refs mat, and you're going to downlink the current refs mat. You can see it's a little bit different from the other one, and that's why we do that. We can go back, and I just wanted to point out that if we take a look at our checklist, TLI plus 90, then TLI plus 4 hour, then the TLI. So a little bit of a strange order, but I'll walk everyone through it. It won't be that bad. First thing we want to do is initialize our mission planning table. So hit MPT initialization. You can go ahead and just click auto and then update, and we can see command module and the S4B. Command module and the S4B. MED, update, update, and update. Then we hit VPS for vector panel summary. Click TLM for our telemetry vectors from the CMC and the instrument unit. Click DC and just hit enter for the current vehicle. We can see our DC vectors got created with API C001 and the time, and then TUP for time of ephemeris. We will take that from the DC vectors. Hit enter, and we can see we have a valid CSM anchor point. Anchor point ID command module 001. And the time that was generated. We can go back and back, and then hit mission planning table and activate. We can see MPT is active. So first steps are TLI plus 90. And the first step to sort of the pre-TLI procedures here is to just hit maneuver targeting, translunar, and then the skeleton flight plan. And now we're going to want to go in and generate that skeleton flight plan. So we'll hit F62. And we can see F62, comma, 1, comma, 72. And we just go ahead and hit enter. And we can see we've got our pre-flight skeleton flight plan loaded for our TLI. We can go ahead, hit back, back again. And now getting TLI on the screen is super easy. You just hit TLI and you'll type in M68, all caps for all letters, comma, CSM, comma, 1, and then semicolon, enter. And we could see that the TLI is on the pad. It's a delta V of 10,515.8. And I mean the mission planning table, that is. We could see what time that ignition will be at. 2 hours, 50 minutes, 35.1 seconds. Now we need to calculate our TLI plus 90. So we'll go ahead and we'll, from the beginning, hit maneuver targeting, and then return to Earth. And we'll take a look at the abort scan table. Specific site. The site for this one is going to be Atlantic Ocean Landing, so AOL. And now we need to pick a time that's after TLI and after undocking. So undocking, we can be generous and say that that's about, 1 hour after TLI. So we'll go ahead and we'll hit in input under here for direct input to MPT. This is going to be a 0 foot per second burn, so that the input on here is going to be super easy. We'll go ahead and just do 3 hours and 50 minutes, and then we'll just go ahead and just cut off the seconds. Page 2 here, and this where it says no change, DOC, this is actually going to be undocking, and the config will just be the command module only. And then we'll go ahead and hit CLC to transfer that to the mission table. We could see there's our undocking 59 minutes later, 0 foot per second burn. And we could see, actually, if you take a look at the code, this is TL for translunar, UD for undocking. Now we just pick a time, which is, 90 minutes after the TLI, and after undocking. So we do 50 plus 90, which is 140. We move one of those hours over. So that's 3 hours. Move another one over. That's 4 hours and 20 minutes. So that's our time of ignition here. 4 hours and 20 minutes. And then for the vector time, we just want to pick a time that's before the ignition. So we'll go with just 4 hours. And now we need the estimated time of the return. And for that, we can actually go ahead and get that TZ information from the transcript. So we'll go ahead and open up the, Apollo 8 flight journal. So Apollo 8 flight journal. And then we'll do day 1, launch and ascent into orbit. Day 1, Earth orbit and TLI. And then we'll just Control F for TLI plus 90. And now we just need to find that time of splashdown. Here we go, 17 hours, 47 minutes, 39 seconds. So we'll go ahead and input that in. 17 hours, 49 minutes, and 47 seconds. Or excuse me, 39 seconds, that is. That small of a time doesn't matter, but just to keep it, exact. Now we hit abort scan table over here and calculate. We can see at 4 hours, 20 minutes, we'll have a burn of 4,817. Perform a direct deep space abort. So basically, about face, turning around, and heading towards the Earth for a splashdown at 17 hours, 49 minutes. 18 seconds at entry interface with a total, or a landing and splashdown at 17 hours, 57 minutes, and 51 seconds. We're just going to go ahead and make sure that that makes sense. So their delta V was 4838.7 and ours is 4817. So that looks really, really good there. Delta X, delta Y, delta Z. Okay, DVT. Here we go, 4838.7, yep. Actually, it's 4858.7. Ours is 4817, so really close. We can go ahead and do return to Earth. This puts up our return to Earth digital's inputs. We'll take the 101. So we're going to output this to the primary column. We'll take 101, and that just corresponds to this here, the code ID here. We'll use the current refs mat, and then this will be a command module, service propulsion system, undocked, and then the last character will always be X for external delta V. Ullage for this burn will be 4 and 0, so 4 space 0. Enter. And that's just because we weigh a lot. We weigh enough to not need ullage. So display and calculate, and we can see our total generation here. We can see that delta V did change just very slightly, 4816.1. Just, you know, the abort scan tables, kind of like an approximation for like planning, and then the digitals after it's been processed. And now we can go ahead and transfer that to the mission planning table. So M74, comma, CSM, no replacement. So we'll do comma to end the CSM input, and then we're not replacing anything, so we will comma again. And then we'll take it from the primary column. So RTEP, return to Earth primary, semicolon, and enter. We could see then we'll have TLI. An hour later, we'll have the undocking, and then 27 minutes later, we'll have the ignition. So that's about that's about 90 minutes. Go ahead and hit back, back, and back, and back again. Going to pre-advisory data, maneuver pad, and then under P30 maneuver, this is for the SPS, there are several options here: P30, P30 LEM, terminal phase initiate, TLI, PDI, whatever. The default one is going to be good for this. So calculate. We'll pull it from the CSM emission planning table, and then we will hit space, and we'll take maneuver number 3. Enter. And this is our, we can see, CCSE 03RE, and that matches, and then RE just stands for return to Earth. And here is our TLI plus 90-minute pad. Now, if we remember, at this point, the thing is asking for a state vector update. So we'll go ahead and we'll hit back. We'll go to uplinks, and then the CMC CSM navigation update. It is not giving us a time for the state vector update, so that just automatically means that it's the present time. We can hit CLC, and then we'll just go ahead and do verb 37, enter 00 on the diski, and flip that to CM accept. And then once you've done that, you can just hit uplink, and that uplink will start. So we don't need to worry about what's on the mission planning table while we're doing this uplink because it's at present time. But just make sure that if it was like a state vector which was in the future, and you have like an abort thing on the table that you're not going to be burning, make sure to remove that from the table, because if you cross that time, you'll get a state vector for if that burn had happened. So just be careful about that. There are the mission planning tables used for generating those state vectors and those instances in which burns really haven't happened yet. You're sort of planning for the future, right? Take that off. Verb 37, enter. 00, enter. And no verb 66 for this one. Now the next up one is the TLI plus 4-hour maneuver pad. So let's go ahead and get the RTCC back out. We'll go ahead and remove the TLI plus 90, so delete M62, comma, DSM, comma, it's maneuver 3, comma, and then D is for deleting in the future, DH is for deleting in the past. So just comma D, and then we'll attach no vector to this, so a blank comma spot, and enter. And you can see that this sort of format that you should be typing is always given to you. So that's nice. We can hit back. Now we'll need the 4 hours. So we'll go maneuver targeting. We'll go return to Earth again, our abort scan table. And this time it will be a mid-Pacific landing, MPL. And the time of ignition will be 4 hours after TLI. With undocking still on the table, that would give us 6 hours, 50 minutes, 35 seconds. And then our splashdown, again, we can grab that from the transcript. And the transcript for the TLI plus 4 hours the time of entry interface, or GET, of 0.05 G is 26 hours. (26 hours, 42 minutes and 57 seconds). So here we go. TZ 26 42 comma 47, enter. And then we just need to pick a vector time close to ignition, so we'll go 6 hours 30 minutes. Abort scan table and calculate. Here we could see ignition 6 hours 50 minutes 35 seconds. And then the delta V will be 5,276. We will compare that here. The delta V will be 5,290.9 in real life, 5,276. So we are very close to the real life delta V. Their velocity at entry interface is 35,061. Ours is 35,000 or 34,990. So again, very close. And that's basically what we want to check for. Just making sure that the TIG lines up nicely, the delta V lines up nicely, and then our VEI lines up pretty nicely. So since this is our second calculation on the scanning table, we will do 102. Again, current refs mat, CSUX. Ullage will be 4 and 0, so no ullage, is verifying those settings have ported over. Display and calculate. And we can see the new digitals have appeared here. So we can go ahead and hit transfer. And this will be M74, comma, CSM, comma, and we're not replacing anything, so a comma again. Well, we could have left TLI plus 90 on the table and then replaced it here with this one, but it's just easier to think of these functions as separate functions, deleting and adding, versus adding while deleting. It's easier to for a first-time person to just think of these as totally separate things. So never replace, just delete and then add as you need. And then the maneuver type will be return to Earth primary, semicolon, and enter. We could see 6 hours, 46 minutes, 57 seconds. That's about 4 hours after TLI, given that delta time is 1 hour and then 3 hours. We can go back and back, back, and back. Now the pad for this, pre-advisory data, maneuver pad, calculate. And notice the old data is actually saved here. So that's pretty cool. The pad system remembers even if it's separate from the mission planning table. So CSM 1, enter. Oh, excuse me, that was 1. I'm at CSM 3. CSM space 3, enter. And we can see that updated information for that abort pad there. If you're interested in seeing what these pads would look like in real life, they don't actually appear like that. They're read up, and that's sort of the astronaut form. It's just an extra tool that has been added for us while we're flying. Makes it pretty easy. But if you're actually reading up that stuff in real life, we can actually take a look at that maneuver pad as it would have been seen in real life. So we could hit MSK 54. And then this is the detailed maneuver table, the FIDO detailed maneuver table. So we hit U20. We could type in U20, comma, CSM, comma, maneuver 3, comma, and then we typed in 54. So we could send it to 54 or 69. We're on table 1, so that's 54. We could see that here. So 54, comma, this will be the current refs mat, and then heads up, enter. And we could see that this is how pad information would look to FIDO and to Capcom, and then it's read up, sort of with information picked and pulled out of this as required. So it's very cluttered here, and that's why the pad generator here is a very nice feature. But yeah, the last thing we need to do is the TLI pad. So we could just go ahead and generate a TLI pad. So pre-advisory data, maneuver, and then we just go all the way to option until we hit TLI and just simply hit calculate. And that'll bring up our TLI pad. And that's it. After that, you've got everything you need ready for your translunar injection. So we can go ahead and wipe out the mission planning table. M62, comma, CSM, comma, 1, comma, D for delete, comma, comma for no vector input, and then semicolon, and that'll wipe it out. You can go ahead and set inactive with the ACT button, and that is all that's required for you for TLI information. So at this point, you can perform TLI, kick back, relax, and then there's a few more activities after undocking, but that will do us for today. So I hope you enjoyed that tutorial there, and thank you very much for watching.